Assalamu alaikum. Today I'm going to teach you how to find out the derivative of tan inverse of x. Now, in order to find out the derivative of tan inverse of x, you need to understand one thing, and that is if I say that f of x is say f of 3 equals to 5. So you can write this as f inverse of 5 equals to 3, and reversely you can write f of 3 equals to 5. Just like that, if I'm saying y equals to tan inverse of x, I can write this as tan of y equals to x. Now if I find out the derivative of both the sides, this will become sec square y dot dy by dx equals to differentiation of x is 1. Why did I write dy by dx on the side? Because whenever you're differentiating y in implicit differentiation, you have to write dy by dx along with it. Now, if I make dy by dx a subject, dy by dx equals to 1 upon sec square y, which is actually, if you use the first identity, 1 plus tan square y equals to sec square y. So sec square y can be written as 1 upon tan square y. And we know tan of y is represented as x. So tan square y will be represented as x square. So the derivative of this will be 1 plus x square. So from here we get to know that the derivative of tan inverse of x is the same as 1 upon 1 plus x square. Now if I change this into y equals to tan inverse of 2x, the derivative of this will be, you don't have to go through this whole process again, you can do it directly. 1 in the numerator, write 2x, square it, plus 1, and then you differentiate this 2x and write it here in the numerator, 2x. The differentiation of 2x is 2, so the answer will be 2 upon 4x square plus 1. This is the derivative of tan inverse of 2x. Okay, let's do a few questions from here. Differentiate with respect to x. The first part, tan inverse of 3x. The method is dy by dx will be equal to 1 upon, take 3x, square it, plus 1, and then you differentiate this 3x and write it here in the numerator, which is 3. So the answer will be 3 upon 9x square plus 1. This is the answer for the first part. Okay, the next part, which is the B part, the question says tan inverse of under root x. Dy by dx is going to be equal to 1 upon, take this, whatever is written with under tan inverse of x, you have to write that, square it, plus 1, and then you differentiate this. Okay, we know that when we differentiate y equals to under root x, the simplest way to differentiate is you write this in the denominator along with 2 and then differentiate what is in the square root and write in the top. This is how we differentiate square roots directly. 1 upon this whole thing in the denominator, 2 is a part of the formula, and then you differentiate this and write it up in the numerator, and this will become the answer. Okay, or if you want to do it the other way, it's x to the power half. When you differentiate it, it will become dy by dx equals to half becomes in front and it becomes a coefficient. Half minus 1 is a minus half. So you can even write it like this, 1 upon 2 under root x here. This is the answer for dy by dx. Okay, so either you do it this way or you do it this way, the answer will be the same. So you're going to differentiate this and multiply it here. So I'm going to multiply it here, 1 upon 2 under root x. Let's simplify this. This will become 1 upon x plus 1 into 2 into 1 upon 2 under root x. So you can write this as 1 upon 2 under root x into x plus 1. This is the answer for the B part. Okay, the next part, the third one is tan inverse of okay tan inverse of x upon x minus 2. So you're going to write this in the 1 in the numerator, dy by dx equals to this whole thing squared plus 1 here, and then you're supposed to differentiate this and write it here. Okay, so if I differentiate y equals to x upon x minus 2 in a rough column or on a side here. Okay, so if I'm going to differentiate, I'm going to use a quotient law here. The quotient law says dy by dx equals to v u dash minus u. I'm short of space here, so I'm just doing it here. Dy by dx equals to v u dash minus u v dash upon v square. So this will become x minus 2 minus x upon x minus 2 the whole square. This will cancel out. You're left with minus 2 upon x minus 2 the whole square. So you have to multiply that here. So I'm going to write minus 2 upon x minus 2 the whole square. Okay, so I'm just drawing a separating line in between. Okay, I need to simplify this further. How will I simplify? I will write dy by dx equals to minus 2 upon x square upon x minus 2 the whole square plus 1 into x minus 2 the whole square. Okay, if I take out the LCM of this, okay, this will become minus 2 upon x minus 2 the whole square is the LCM. So this will be x square plus x minus 2 the whole square into 1 upon x minus 2 the whole square. This is going to give me a okay, I made a mistake here. This was actually minus 2 upon x minus 2 the whole square. Okay, so this will become x minus 2 the whole square. This and this will cancel out. We are left with minus 2 upon x square plus, if I expand this bracket, x minus 2 the whole square, this will become x square minus 4x plus 4. So it's minus 2 upon 2x square minus 4x plus 4. If I take out 2 as common from here, I'll be left with x square minus 2x plus 2. Minus and minus will cancel out, leaving minus 1 upon x square minus 2x plus 2 as the final answer. Okay, now we need to start with this exercise. Okay, this is the exercise which says differentiate with respect to x. The first one, if I do question number 1, the a part, tan inverse of 2x. I've done this before, but I'm doing it again. This will give me tan inverse of 2x. So if I want to differentiate this, y equals to tan inverse of 2x, dy by dx is going to be, I'm going to write 1 on the top, 2x the whole square plus 1, and then I'm going to differentiate 2x and write it here. So it's 2. So 2 upon 4x square plus 1 becomes the answer. Okay. The b part, question number 1, the b part, which is tan inverse of 5x. Okay, in this also, if y equals to tan inverse of 5x, dy by dx is going to be 1 upon, take 5x square it plus 1. Okay, then you differentiate this part, and this is the differentiation of 5x is 5, so you multiply it by 5. So the answer becomes 5 upon 25x square plus 1. This is the final answer for the b part. Okay, moving on to the c part then. The c part is tan inverse of x upon 3. Okay. In order to differentiate this, I'm going to write y equals to tan inverse of x upon 3, and I want to differentiate it. dy by dx will be 1 upon x upon 3 the whole square plus 1, and then I'm going to differentiate 1 upon 3x, which is going to give me 1 upon 3 only, so I'm going to write 1 upon 3 here. So this is giving me 1 upon 3 x square upon 9 plus 1. If I want, I can simplify it further, taking out the LCM of 9 and 1. So this will become x square plus 9. Okay, if I simplify it 3 1 times, 3 times, I'm left with 1 divided by x square plus 9 upon 3, which is actually 3 upon, you'll reciprocate the fraction following the division sign. So this will be the answer for the C part of question number 1. Then there are 3 parts. There are there are 6 parts to question number 1. I am doing the D part now. Okay, it says tan inverse of x minus 3. So y equals to tan inverse of x minus 1. So when you will differentiate it, the method remains the same. 1 on the top. Take this, whatever is written with tan inverse, write it and square it, plus 1 here, and then you differentiate this bracket. When you differentiate this bracket, you will get a 1 only. Okay, because x minus 1, the differential will be 1 only. Differentiation of 1 is 0. So this will become 1 upon x square minus 2x plus 1 plus 1, which is giving us 1 upon x square minus 2x plus 2. This is the final answer for the D part. The E part, tan inverse of x upon 2. Y equals to tan inverse of x square. So dy by dx is going to be 1 upon x square, you square it, plus 1, and then differentiate it, you'll get 2x. Differentiation of x square is 2x. Okay, if you want, you can do it in the rough column also. Dy by dx is going to be 2x. Differentiation of x square. Okay, simplify this, it will become 2x upon x4 plus 1. This is the final answer. Okay, the last part of question number 1, the F part. Y equals to 2x upon x plus 1. Tan inverse of so dy by dx is going to be 1 upon, take this whole thing, square it, plus 1, differentiate this. Okay, so I'm going to differentiate it here. Y equals to 2x upon x plus 1. I am differentiating it, so I'm going to apply the formula there. Previously, when I differentiated this with quotient law, I did it directly. Now I'm doing it with the formula, because most of the students, they do it with the formula. So if it is y equals to u upon v, dy by dx is v u dash minus u v dash upon v square. Okay, now in this particular question, if you notice, u is 2x, so u dash is going to be 2, and v equals to x plus 1, so v dash is going to be 1 only. Okay, let's apply the formula. Dy by dx equals to v u dash minus u v dash upon v square. This is giving me 2x plus 2 minus 2x upon x plus 1 the whole square. This and this will cancel out. You're left with 2 upon x plus 1 the whole square. Okay, so we've differentiated this here, and the result of the differentiation is here, which we are going to copy and write it here. Okay, so you're going to multiply it, because the differentiation of tan inverse of whatever is in the bracket, you're going to always write 1 upon that thing squared plus 1, and then you differentiate this, which I've differentiated here. So I'm multiplying it here. So it's going to be 2 upon x plus 1 the whole square. Okay, let's simplify it further. This is going to give me a 2 in the numerator. If I solve this part firstly, I will get 4x square upon x plus 1 the whole square plus 1 Okay, and then you've got 1 upon x plus 1 the whole square here. Okay, so let's simplify this first. I'm taking out the LCM of these two fractions. The LCM will be x plus 1 the whole square. X plus 1 the whole square. X plus 1 the whole square. So this will be 4x square plus x plus 1 the whole square, multiplied by 1 upon x plus 1 the whole square, which is going to be 2 upon 4x square plus, if I open this bracket, I will get x square plus 2x plus 1 upon x square plus 2x plus 1 upon x plus 1 the whole square. Okay, multiplied by x plus 1 the whole square. This and this will cancel out, leaving 2 upon 5x square plus 2x plus 1 as the final answer. Okay, then we're going to do question number 2, all the parts. Okay, so let's do the first part, question number 2a. Y equals to x tan inverse of x. So here we have to apply the quotient rule, which is uv would be dy by dx is uv dash plus vu dash. Okay, so let's start with this. In this we know that u is tan x, so u dash is going to be sec square x, and then if you notice, u equals to tan x, so u dash is going to be sec square x. No, u is equals to x, obviously. I'm so sorry. U equals to x, so u dash is going to be 1, and v equals to tan inverse of x. Okay, so v dash is going to be, we know in differentiation of tan square x, tan inverse of x is 1 upon x square plus 1. So let's apply it in the formula. Dy by dx equals to u v dash plus v is tan inverse of x, v u dash is a 1. So the answer would be x upon x square plus 1 plus tan inverse of x. Okay, this is the answer for the A part. Okay, moving on to the B part, where we have to differentiate tan inverse of 2x upon x. Okay, okay, so it's going to be this is y v equals to u upon v. We have to apply quotient rule here, which is dy by dx is going to be v u dash minus u v dash upon v square. So this is going to be dy by dx equals to v is, if I do it here, tan inverse of 2x is u, so u dash is going to be, if you have to differentiate this will become 2x the whole square plus 1 into 2. When you differentiate 2x, you get 2, so it's actually 2 upon 4x square plus 1. So u dash is this, and v we know as x, so v dash is going to be 1. Okay, let's plug it in the formula. V is x into u dash, which is 2 upon 4x square plus 1, minus u is tan inverse of 2x into v dash, which is actually 1 upon v square. V square would be x square. This is going to give us 2x upon 4x square plus 1 minus tan inverse of 2x upon x square. Okay, so since you have to divide it by 2 by x square, you will write 2x upon 4x square plus 1 minus, if you want you can take out the LCM first, which will be 4x square plus 1 of the numerator. So this will be 2x minus 4x square plus 1 into tan inverse of 2x divided by x square, which is 1 upon x square. So this will become minus 4x square plus 1 into tan inverse of 2x upon x square into 4x square plus 1. This is the final answer. Okay, the last part, which is e to the power x into tan inverse of x. Okay, so the last part is this. Okay, so u equals to if y equals to ex tan inverse of x, dy by dx would be, okay, in this case u is ex. Once again we have to apply the product law, so u dash is going to be ex only. V is tan inverse of x, so v dash is going to be 1 upon x square plus 1. Okay, so once again product law, u v dash, u into v dash plus v into u dash, that is it. So ex upon x square plus 1 plus ex into tan inverse of x. If you want you can take out e to the power x is common, you will be left with 1 upon x square plus 1 plus tan inverse of x. That is it. This will be the answer for the last part of question number 2. Now we just have to do one more question, and that is the last part here, question number 3. Okay, question number 3 here. Okay, find the equation of the tangent to the curve at the point where x equals to 2. Okay, so equation of the tangent to the curve. So y equals to tan inverse of x upon 2. You will have to differentiate this tan inverse of x upon 2. The differentiation is not difficult. What you will have to do in this case is when you have to differentiate this, you will write 1 upon x upon 2 the whole square plus 1, and then x upon 2, when you differentiate it will become 1 upon 2 only. So I have to write 1 upon 2 here. So let's simplify this. It will become x square upon 4 plus 1 into half. Okay, into half. So I'm going to simplify it further. I will write x square upon 2 plus 2. Because I multiplied 2 by x square upon 4 plus 1, I got x square upon 2 plus 2. Okay, so this has come in. This is the differentiation, but I'm going to simplify it further. The denominator is 2. So x square plus 4 here. So 1 divided by x square plus 4 upon 2 will become 1 multiplied by 2 upon x square plus 4. So the dy by dx equals to 2 upon x square plus 4, and we know that the value of x is 2. So dy by dx at x equals to 2 would be 2 upon 2 square plus 4, which is 2 upon 8, which is 1 upon 4. So we know the gradient is 1 upon 4. So y minus y1 equals to mx minus x1. We need to find out the value of y when x equals to 2. Okay, finding y when x equals to 2. So you have to pick the main equation. Y equals to tan inverse, y equals to tan inverse of x upon 2. So this will become y equals to tan inverse of 2 upon 2, which is a 1. And we know tan inverse of 1 is pi by 4 in terms of radians. So the coordinate which we have is 2 comma pi by 4. Okay, so using gradient equals to 1 upon 4 and 2 comma pi by 4, we have to find out the equation y minus y1 equals to mx minus x1. Y minus pi by 4 equals to gradient is 1 upon 4 x minus 2. Let's simplify this. Y minus pi by 4 equals to 1 upon 4 x minus 1 upon 2. Pi by 4 I'm shifting it to that side. Y equals to 1 upon 4 x minus half plus pi by 4. I'm taking out the LCM of this side, which is going to give me x minus 2 plus pi. Cross multiplying 4y equals to x plus pi minus 2. I'm shifting 4y to that side, x minus 4y, and pi minus 2 when it shifts to this side become 2 minus pi. So this is the equation of the tangent to the curve. So in this video today we have learned how to differentiate the tan inverse function. Thank you so much for watching the video.